Hello guys, today we are learning about the QAM, means that quadrature amplitude modulation. This is also a type of modulation which are we used in the transmission lines, that is in our communication system. In QAM, two message signals. Here we are using two message signals M1 and M2. We have to consider first. M1 and M2 are the message signal and C of t. We have considered the C of t is a carrier signal with here we are using two carrier signals with phase shift of 0 and the 90 degrees phase shift respectively. In QAM, both amplitude and phase gets modulated except the frequency. The phase and the amplitude are modulated. That's why here we the QAM is called as quadrature carrier multiplexing. This is the block diagram of the QAM. Here we are using two message signals. Then two message signals are passed through the QAM modulator. Then we get the S of t, the standard signal. Now we have to go through the QAM transmitter, that is also known as modulator. Here we are using serial to parallel converter. First we have to give the binary data, which are we used in the ones and zeros, the binary data. Then we have to give that the binary data to the serial to parallel converter. Then here we have to use the two converters, that is digital to analog converter, digital to analog converter. The digital signal is modulated into the analog here through what the serial to parallel converters. The serial to parallel converters are converted into the DAC, digital analog signals. Then the two signals are passed through a PAM, means product modulator. PAM product modulator 1 and the second one is PAM product modulator 2. The two message signals are passed through a PAM, two PAM signals. Here the PAM1 has a 90 degrees phase shift with the PAM respect to the message signal. The carrier signal is 90 degrees phase shift. Then the two message signals are passed through a summer. The summer is as the two signals which are coming from the PM modulators. That here we have to get the S of t standard wave of the QAM modulator. See, once there is a binary data, then we have to convert them into parallel. Then we have to pass it into first we have to convert them into serial to parallel message signals. Then we have to pass it through the DAC converters. The digital to analog converters are given. Then we have to pass it through the PM modulators, that is product modulator. Then we have to pass it through them summer, that is also summer called as summer and adder. Then we have to get the summation signal, two sum signals, that is standard wave signal. Here we have to go through the now theory. By using serial to parallel converter, the input serial data is converted into the parallel. Here we have using that the serial to parallel converter. By using this, the parallel the series data are divided in passed in the converted into the parallel. By using DAC, the digital to analog converter, the message signal which are we have passed through the serial to parallel converter, digital signal is converted into the analog signal. Here it generates two message signal, M1 of t, M2 of t. We have seen that M1 of t and M2 of t. Then we have to pass it through two message signal into a product modulator, that is P1 and P12, PM12, PM22. Next we have the two product modulators which are multiplied. The product modulator means which multiplies the two signals. Here the two signals are carrier signal and the message signal. The two signals are multiplied here and then is passed through a summer, that is adder. We also known as adder. Then the standard equation like this: AC m1 of t cos 2 pi fct. The first signal, the the PM signal is first like this. Then the message signal which are we pass the 90 degrees phase shift carrier signal. Here The second signal is passed through a 90 degrees phase shifter. That's why the cos signal is converted into the sine signal, which is 90 degrees phase shifter. The AC m1 of t into sine 2 pi f c t. The output of the both product modulator is passed through a summer, that is summer block. We have seen that summer block. Here adder means summer. Mm, the summer block, then we get the s of t, that is standard wave signal. That's a standard wave of the QAM transmitter. The QAM transmitter standard wave signals are S of t is equal to AC m1 of t cos 2 pi f c t plus m2 of t sin 2 pi f c t. Here the two signals are gone through the adder. That's why the two signals are mm, get summed. That's why the two signals are get summation. Here then we have to move to the QAM receiver, that is also called as demodulator or detection also. Uh, the QAM receiver has same like the transmitter. Here we are using the PM1 and PM2, the two product modulators, and also 190 degrees phase shift AC cos 2 pi FCT, and one is zero phase shift P1 of t, that is LP. Here we have to demodulate any signal, means there we have to use the low pass filter, because to eliminate the high frequency carrier signal. That's why LPF is used here. Then after the usage of LPF, then we have to get the normal original signal